Hey, Bio2 students, Mr. Yance again. Let's continue on with some genetics notes here. So I think probably one more day of notes after this one. We'll have it, and then we will take a test, okay? So I kind of left off with this screen the other day. Pedigrees is just a chart that shows a family tree, and basically it allows us to trace genes or diseases or bloodlines. Ancestry.com, all these websites that are out there, 23andMe, that's basically, they're doing a form of pedigree, except they're just trying to figure out, oh, your family comes from, Russia or Germany or whatever. So this takes it to another level. So let's go through a little bit of symbols that will help you when you do your assignment that I'm going to post on Google Classroom. Anytime you see a square represents a male, a circle represents a female, and then if they're shaded in, that means that they're affected. Okay, so they have a disease, they have a trait or whatever. Lines connecting a square to circle means we have mating, or it's a husband and wife, or that's where we had a pregnancy. And then birth order always goes from left to right. So this circle, that would be a female, was the firstborn, and then a boy, then a boy, then a boy. Okay? So the lines have meaning, the symbols have meaning, and if they're shaded in halfway or all the way, or they have a dot, that tells you a lot about what you're looking at. So let's look at an example here. So here is widow's peak. Means your hairline comes down to a V. Mine used to, but I'm losing my hair. So you can see this lady has it. This one does not. It goes straight across. So if you see, here's the first generation. Here's the grandparents. And let's see if widow's peak is dominant or recessive. So we have a big W, little w, heterozygous, homozygous. And then all of a sudden, this first girl had a widow's peak, and the youngest boy had a widow's peak. All right. And you can see that with the W's that this is going to tell me it's dominant, right? Because it doesn't matter if you're homozygous or heterozygous. If you get a big W, then you have that trait. So you can tell by percentages if something's dominant or recessive. And I think that's important stuff to know. Let's try another one. So let's look at if you have, these are just common traits. So you have attached earlobes or you have a free earlobe. I have a free one that kind of hangs down, whereas other people goes right into their side of their neck. So here's the first generation, okay? This person had little f. Then we had you can see the two boys in the middle here have the attached earlobe. The ones over here does not, and they married and they have this one. So this one obviously would be recessive, right? So if you don't have the symbols in there, you still can go through and figure this out. So we'll do a little assignment on this where I'll have a dash in there, and you're trying to tell me, is it a big F or a little f or whatever. So if we don't know if they're homozygous or heterozygous, then we put a dash in there, and then you can look at the offspring, and you sometimes can figure it out. All right. So pedigrees are kind of fun to play with, and we'll do we'll do a little exercise on that when we do our Google Classroom assignment. So let's look at some recessively inherited disorders. Luckily, most genetic disorders out there are recessive. That's good. That makes diseases pretty rare, and the chance of two carriers meeting is low. Unfortunately, I don't know if you remember this from Bio 1 days, but I showed how hemophilia actually came from the royal family, and the reason it came through the royal family back in the day is because of the consanguineous matings. That's a mouthful, by the way, which simply means matings between close relatives. Okay. That's why we don't like to do that, because it increases the chance of passing diseases on. And most societies and cultures have laws, or it's just taboo. You just don't marry close relatives, not that it's because of this right? But it's because genetic-wise, the closer your bloodlines, the higher chance you have of passing certain diseases on to the offspring. Okay, so that's why that is in there, and that's why there's we have laws in this country about that. It's just a good idea to try to keep these as low as possible. Okay, so let's look at some examples. I just want to go over a few recessive disorders you might run into. Cystic fibrosis is one. It is a good test question. This is the most common lethal genetic disease in the United States. It strikes 1 out of every 2,500 people of European descent, which is kind of crazy when you think about that. It came from Europe. I don't know if you guys know what this is. I've had some students with this in the past. Is your lungs fill up with fluid, and they have to literally beat on your chest to get that out. And so you got to be really careful with bronchitis and colds and COVID-19 and those types of things, okay? And basically, it's just a defective gene, and what's absent is something called a chloride transport channel, which may not seem like much, but what happens is mucus will then build up in your organs and in your lungs, and eventually catches up with the person. Now, we've increased lifespans with this disease. We still don't have a cure for it, but we do have better treatments for it and people living longer lives with it. So cystic fibrosis is one of those that we'd like to wipe out someday through gene therapies and things like that. So that's recessive. You got to have 2 recessive genes to get that. All right. Let's look at another one. Sickle cell disease is another common one. 1 out of every 400, but it's mainly in the African Americans. Okay. And it's caused by a disease. It's just simply a substitution of a single amino acid. So you wouldn't think, again, just one single amino acid would cause a big deal. But in hemoglobin, and this is where the name comes from, it causes your cells to be half moon-shaped instead of round. And if they're not round or oval, they don't pick up oxygen. So you can see why these symptoms are going to be like this. It's because you're going to have some weakness, you're going to have pain, you're going to have organ damage, even in some people paralysis. Another one where we've increased the lifespans of people, but eventually sickle cell anemia catches up with the person as well, even though we can do blood transfusions and stuff like that. All right. Dominantly inherited disorders are the ones we really fear the most because they're more common. Luckily, there's not a lot of these, but I want to go over a couple of them. They are where and you can see they're rare, thank goodness. But achondroplasia is dwarfism, more commonly referred to. It is actually a rare dominant allele. And let me explain this a little bit. So let me put this up here. And this is how it gets inherited. It is a dominant gene, as you can see from the Punnett square. Here's the big thing. People get confused. What is a midget? What is a dwarf? A dwarf means you're miniaturized all over. Your torso, your legs, your arms, your whole body is this a miniaturized version of normal. Midgets have a normal torso. They just have extremely short arms and legs. A midget, my wife had a roommate in college who was a midget, and she had 3 sons, 2 of which are like 6'5", and 1 is a midget. But she had them, she got pregnant and had regular childbirth. Dwarfs cannot do that. So the females anyway. So that is the problem that's the difference between dwarfism and a midget. They are different, but you can see why it's bad because it is a dominant allele, okay, which causes some problems, okay. This one might be, clicked one too many times. This one could be probably even more, this is a more common one that we fear. Huntington's disease is a degenerative disease of the nervous system. And I'll tell you a story and I'll finish up with those for today. But this disease has no obvious phenotypic effects until you're about 35 to 40. And what happens is it's a disease where you have a buildup of fatty tissue in the brain, and that's a defective gene. You usually get rid of that. Huntington's disease people do not. I had a neighbor that his dad, he was in my class. I guess he was a year behind me. He's a friend of mine just around the corner from me. And his dad was perfectly normal until he hit about 40. And then he literally lost his mind. He became abusive. He became very angry. He just was not his self. Okay. Hang on a second. Sorry about that. My wife calls, you got to answer. So here's the thing. He was perfectly fine, and he just lost his mind. He ended up being institutionalized, and he died when he's 45. Awful. I mean, he was the most normal guy, fun guy, just a great guy until he hit that age, and he didn't know it, and he was an only child. And what's bad is you have a 50-50 chance of getting this disease because it is a dominant gene, right? 50-50 chance, okay? What happened was, 50-50 chance if you're heterozygous, right? So he could have got tested, but he decided not to, and he adopted. Now he's in his 50s, and he got lucky and didn't get the disease. So I think that's something to think about. Some people say, why wouldn't you get tested? Well, I talked to him not too many years afterwards. He says, I don't want to live my life differently. If I know I'm going to get this disease and die, I'd rather just live my life like I normally would. And, that's one way of looking at it. Other people are like, I like to know so I can do some things maybe I wouldn't have done when I was younger. So just awful diseases because they're dominant diseases. All right. Okay. We'll stop there. Hopefully that makes sense. Got questions, you know what to do. Email me. And have a good day, and we'll pick up there later. See you. Bye.